Welcome to video number 2. We're going to talk about the order of operations now. And I know most of you have heard this as PEMDAS. So let's start with the first thing, P. And I say, instead of P, we should call this GEMDAS with a G. Because the P stands for parentheses, but what you actually mean is grouping symbols. And there are more grouping symbols than just parentheses. You can have parentheses, that's the most common, but we have brackets and we have the braces. Your fraction bar can also be a grouping symbol as well as absolute value. So there's more grouping symbols than just parentheses. But whatever they are, you do them first. Now within the grouping symbol, like within the parentheses, you're going to perform these in this order. So that's all it means. You start inside and you work your way out. So you're going to locate your grouping symbols. Now, parentheses, brackets, braces, they're all the same. They all have the same weight. We have different things because if you have a string of numbers, it's easier to tell what to do when you have these separated. For example, if I needed to group more than one group, and you just start putting a whole bunch of parentheses, it gets confusing. But if you alternate parentheses, brackets, it's a little bit easier to see exactly what is grouped together. Our next step is the E. That's for exponents. So now, let's have a brief refresher in our exponent rules. In this example, this is read 2 to the 3rd power, 2 to the 4th power, 2 to the 5th power. This is your base. The big number is your base. Remember, B and B, big number base. This is your exponent. An exponent tells you how many times to multiply that base times itself. So what this means in expanded form is 2 times 2 times 2. Let's look at the difference between an exponent and a coefficient. For these two examples, I've got x to the 3rd and I've got 3x. Here, 3 is my exponent. Here, 3 is my coefficient. Now I just told you that an exponent tells you how many times to multiply that base times itself. A coefficient tells you how many times to add that number with itself. So this would be x plus x plus x. Alright, exponents tell you how many times to multiply, coefficients tell you how many times to add. Now let's talk about combining terms that have exponents. When you add or subtract, your exponents have to match. And all you do is change the coefficient. When you are adding and subtracting, that never changes your exponent. So in this example, 3x squared plus 5x squared, you add your coefficients, that's going to be 8x squared. You don't have any x to the 4th. Nothing changes about your exponent in addition. Now let's look at multiplication. If I have x to the 2nd times x to the 3rd, if you expand this out, and you're not going to want to do this every time, but if you expand this out, what you actually have here is x times x times x times x times x. Now remember, an exponent tells you how many times you multiply the base times itself. So how many times is this base multiplied by itself? 5 times. And yes, you can take a shortcut. If you have two bases with two exponents, you can just add the exponents together to get your new exponents. You don't have to write this out every time. Let's look at this problem. Now I have x to the 2nd to the 3rd. If I wanted to do expanded version, go to the outside first. This tells me to multiply x to the 2nd times itself 3 times. If I expand that out, what did I do? Now I've got how many x's? 6 x's. So simplified form would be x to the 6th. Now in this example, I have one base with 2 exponents. Then you can multiply. That's what the rule tells you. One base two exponents, you can multiply your exponents and get 6. Okay, so let's see what this one would be. 3x to the second times 5x to the third. Now, your exponents don't have to match when you multiply, remember that. What you're going to do here is multiply your coefficients together. 3 times 5 is 15. Your base is going to stay x. Now what's going to change is your exponents. You've got two bases, two exponents, so you can add the exponents and get 15x to the fifth. There is something interesting that can happen to a negative base when it's raised to an exponent, but there are certain criteria that have to be met. So let's look at the perfect scenario. First of all, I have -3 to the 4th power. Now expanded, what this means is -3 times -3 times -3 times -3. What happens when you multiply two negatives together? You get a positive. So these two would cancel each other out. These two would cancel each other out. So this actually results in a positive answer because the negatives all cancel out. But let's look at this one down here. Skip down here. If I have -3 times -3 times -3, well, a negative times a negative is a positive, but then you have one more negative. So this answer would be -27. So the first rule is if it's going to change this from positive to, or from negative to positive, your exponent has to be even. If you have an odd exponent, you're still going to get a negative answer. Now, in both of these, your negative was inside the parentheses and your exponent is outside. That's the only time that base can change from a negative to a positive. What happens right here is this exponent can only affect the number. So in expanded form, what you actually have is -3 times 3 times 3 times 3, sorry. So what you're going to get here is -81. So look at the differences in these three examples. Inside the parentheses, outside the parentheses. No parentheses, and then this one has an odd exponent. So let's get into the whole PEMDAS process now, or GEMDAS as I call it. Grouping, exponents, multiplication, division, addition, subtraction. I know everybody in here has seen those social media posts where somebody puts an expression up there and the arguments in the comment section are hilarious. People think they understand what this means, but a lot of times, and it's right here in steps 3 and 4, where people get confused. And they get confused because there's 6 letters in PEMDAS, but this is actually a 4-step process. You do the grouping, all your parentheses, fraction bars, everything like that. Simplify within those as much as you can. Take care of your exponents. For step 3, technically this is not 2 steps. It's 1 step, 1 pass. You do multiplication or division as you come to it from left to right. Same thing with step 4. You do addition or subtraction as you come to it from left to right. Multiplication is not better than division. This is where most people mess up. They want to go through and do all the multiplication and then go back through and do all the division. You don't do that. You're going to make one pass to the right and you're going to do whichever one comes first. Same thing with addition or subtraction. Let's look at an example. Let's take 16 divided by 2 times 2 plus 2. And if you want to, pause the video, work it out real quick, and then come back and see if you got the right answer. So we're going to start within the grouping symbols first. 2 plus 2 is 4. So now what I have is 16 divided by 2 times 4. There are no exponents, so we're moving on to step 3. What people usually want to do right here is they want to come over here and multiply 2 times 4 first. No, that's not the way we do this. We're going to go back to the left and we're going to start and work our way. Any multiplication or division. 16 divided by 2 gives me 8. So now what I have is 8 times 4, which is 32. Okay, I want to break for just a second and talk about this word, a term, because you will hear me say this frequently. Do this to a term or do that to a term. You need to really know what a term is. A term is a number and any variables that are multiplied together. For example, 3x is a term. 4xy is a term. xyz is a term even though it doesn't have a number in front of it because it's the understood one. Terms are separated by plus and minus signs. So up here there are 3 terms. 6x is a term, 5y is a term, and 7 is a term. Now 7 is a very special term. It's called a constant term. These two are called variable terms because they have a variable in them. They can vary. They change depending on what x and y are. 7 is a constant. It never changes, but it's still a term. Now let's talk about the term coefficient real quick. Usually when you say the term coefficient, we think the number in front of all the variables. Even if there's not a number there, it's understood to be 1. But technically, by definition, a coefficient is the product of the remaining numbers or variables or letters. So if a question says, what is the coefficient of x? Given this, it would be 5yz. It's whatever's left over. But if you're not told something like of after coefficient, we're just going to assume that we're talking about this number right here. Okay, let's look at some examples. Now, I am working from the textbook on openstacks.org, and there's a link in the description of that. These are the example problems on page 16. We have 3 times 2 squared minus 4 parentheses 6 plus 2. So according to our order of operations, let's do our grouping symbols first. So 3 times 2 is going to be 6 minus 4. Alright, 6 plus 2 is 8. Now let's do our exponent. So we have 36 minus 4 times 8. Now we're into step 3, which says do multiplication or division as you come to it from left to right. So let's go to the left. This is minus. I'm not doing that. But what's 4 times 8? 4 times 8 is 32. So now I have 36 minus 32. Correct answer is 4. Okay, now problem B, and this is still from page 16. If you want to, pause the video and you work it and see if you get the right answer. That'll probably help you more than just watching me go through it. Alright, so you have grouping symbols here. You have this fraction bar. What's grouped is what's up here on the top. So let's do that top first. Now within that group, I'm still going to adhere to the order of operations. So I'm going to do my exponent first, which is 25 minus 4 over 7. Now what's 25 minus 4? So now I have 21 over 7. Okay, this radical sign is a grouping symbol. I have to do what's under it first. So what's 11 minus 2? 9. And what's the square root of 9? You can simplify that because the square root is actually an exponent. So what is the square root of 9? 3. Okay, now let's come here. This fraction can be simplified, and also according to the order of operations, what do you do first? You do division. A fraction is division. So 21 divided by 7 is 3 minus 3, which is 0. Here's our next example. 6 minus absolute value 5 minus 8 plus 3 times parenthesis 4 minus 1. So let's go through PEMDAS. First is your grouping symbols. Now remember I said absolute value signs can be a grouping symbol. So let's do what's in there first. And let me do it this way. What is 5 minus 8? Well, that's going to be negative 3. Here's another grouping symbol. What's 4 minus 1? That's 3 as well. Now let me come under here and clean this up a little bit. 6 minus, what is the absolute value of negative 3? Positive 3 plus 3 times 3. So this is what our problem looks like at this point. Alright, still following PEMDAS. I've done grouping symbols. There are no exponents, so I'm ready to move to multiplication or division. I'm going to skip right on through here because all this is addition, subtraction. Now when I get to here, I have multiplication. What's 3 times 3? 9. So my problem at this point looks like this. And we're ready for the last step. Now like I said, you do addition or subtraction. So you don't skip over here and add first. You're going to do subtraction. 6 minus 3 is 3, plus 9 leaves you with a correct answer of 12. Here's example D. I've got 14 minus 3 times 2 all over 2 times 5 minus 3 squared. So, grouping symbol. This fraction bar is a grouping symbol. We need to do what's on the top as much as we can, and then do what's on the bottom as much as we can, and then we'll divide those things. So let's start with the top. Now within this group, we're still going to adhere to PEMDAS. There's no other grouping symbols up here. There's no exponents, but I am going to do multiplication or division first as I come to it. So I'm skipping over to here. 3 times 2 is 6. So what I have is 14 minus 6. Then I'm going to subtract 14 minus 6 and get 8. Alright, now let's come down here on the bottom. There's no grouping symbols within this, but there is exponents. So what is 3 squared? 9. So now I have 2 times 5 minus 9. According to PEMDAS, I'm going to start at my left and work my way to the right, and I'm going to do multiplication or division first. So 2 times 5 is 10. So now I have 10 minus 9, which is 1. And what is 8 divided by 1, or 8 over 1? Is just 8. Okay, we're ready for our last example. And this is a long one, but you know, you're fine. That's why we have PEMDAS. It helps us go through a problem in a proper order. Remember, you can only work with numbers 2 at a time anyway. It doesn't matter if there's 2 numbers or 200. You're going to try to figure out which 2 you need to be doing when. And that's what the order of operations tells you. And it's kind of interesting, you know, the order of operations wasn't developed until the early 1900s. We figured out that, you know, people were getting different answers to the same expression, and that was not a good thing. Math is supposed to be consistent, and you need to interpret a problem and get the same answer that the person who wrote the problem intended. Otherwise, it just creates one big mess. So let's get in here and let's apply the order of operations. First, we're going to do parentheses or your grouping symbols, because you see here I have brackets. Now remember, they're the same. They have the same weight as parentheses. It just helps us visually see what's grouped together. If you want to, pause the video right here and then see if you get the right answer. Okay. All right. Let me go inside the parentheses first, and what I'm going to use a different color. 5 times 3 is 15. I'm going to come over here. 6 minus 3 is 3. Alright, let me come under and clean this up. So now I have 7 times 15 minus 2 times 3 minus 4 squared plus 1. Still following PEMDAS, I need to do exponents. Within this grouping set, you're going to apply PEMDAS. So within here, I'm going to do 4 squared, which is 16, and then I'm going to say, okay, 3 minus 16 is negative 13. And you can put that in parentheses. Like I said, parentheses and brackets are the same. You can alternate if you want to, or you can standardize. So my problem at this point looks like this, which is getting to be much better. In this step, we're ready to go to the left and perform the multiplication that we have, or division. We don't have any division, so we're just going to take care of the multiplication. Now, 7 times 15 is 105, and 2 times negative 13 is negative 26, and 1 is here. Now, I put this in parentheses just to group the negative sign with its number. Now what happens when you have minus a negative? They cancel each other out and become plus a positive. So when you add 105 plus 26 is 131, plus 1 is 132. So how did you do? Good job. And you just made it through the second lesson for college algebra. Congrats. So you should be ready for video number 3. I'll see you there.